It is now your turn to try to solve an equation by factoring. If you have not yet solved the equation y to the third plus 9y squared equals negative 20y on your own in your packet, please pause the video, do this in your packet, then return to the video to check your work. To solve the equation y to the third plus 9y squared equals negative 20y by factoring, the first step has to be to set the equation equal to 0. To set this equation equal to 0, we will add 20y to both sides of the equation. Adding 20y to both sides of the equation will give us y to the third plus 9y squared plus 20y equals 0. Before we start our factoring process, we should recognize that this equation right now does not fit the standard form of a quadratic equation. It's not a quadratic equation because we have a y to the third. Quadratic equations are always the variable squared. That being said, it doesn't mean we can't factor this. We will use our regular factoring process. The first step in factoring is always to look for a greatest common factor. When we look at y to the third, 9y squared, and 20y, we should recognize that all three of those terms have a y on them. So we will factor that greatest common factor of y out, and that will leave us with y squared plus 9y plus 20 equal to 0. So we now have y times the quantity y squared plus 9y plus 20 equals 0. If we look at what's left in parentheses, we do see that we now have finally a trinomial, and it's the standard sort of quadratic trinomial. Not only that, it's one of the nice ones. The a value is 1. So our attention turns to the c value, because we need to figure out what multiplies to make c and adds to make b. The c value is 20. It's a positive 20, telling us the numbers, the factors that we're looking for, are going to be the same sign. The fact that they need to add to make a positive 9 for our b value means they both have to be positive. So numbers that are both positive and multiply to make 20, there is 1 and 20, but that adds to make 21, not 9. There is 2 and 10, that adds to make 12, not 9. And then there is 4 and 5. 4 times 5 is 20, and 4 plus 5 is 9. So we can continue factoring the trinomial. We'll have the greatest common factor of y still out front, but the trinomial piece will factor as y plus 4 times y plus 5, and that will equal 0. We've now factored the polynomial that we were given, and so we now have three separate things that multiply to make 0. It is important to recognize that any one of those things could be the piece that was actually equal to 0. So we will split this into three separate equations. Either the first factor of y equals 0, or maybe it's the y plus 4 that equals 0, or possibly it is the y plus 5 that equals 0. To solve each one of those resulting equations, y equal to 0 is already solved. To solve y plus 4 equals 0, we'll subtract negative 4 from both sides to get y equals negative 4. And to solve y plus 5 equals 0, we'll subtract 5 from both sides and get y equals negative 5. What is different about this equation than some of the others we have seen is this equation has three solutions. But even so, if we check these solutions against the original equation, put 0 in for all the y's, put negative 4 in for all the y's, or put negative 5 in for all the y's, each one of them individually will give us a true statement. Again, I'm going to leave the check for you to do on your own, but once you have verified that 0, negative 4, and negative 5 are solutions for this equation, we can give our conclusion. The solution set is the set 0, negative 4, negative 5.